Hello and welcome to part 3 of part 2. This is, if you have a NDA in place, this is the confidential portion. You can only see this part under NDA, and please contact us if you need one. Now obviously if you've got this video you should have an NDA. If you don't have one, if you don't have one and you've got this video, stop now and write to us and ask us for one, because we will take this seriously. We will talk about people who get this video and we find out about it and look at it who don't have an NDA. So if you are in question about whether you have a non-disclosure agreement in place, if you don't know that you have one in place, I would politely and professionally ask you to stop now and check. And if you do not have one in place, please ask us for one. And if you do have one in place, then come back and enjoy the presentation. That's what we have to say about that. So what I want to deal now with is associations and what they give us. We touched on it lightly, but this next piece is a piece of the presentation that I've given this presentation, I don't know how many times, maybe 20, 30 times. Since we invented this in 2002, 2003. I remember I invented this in 2002. Can't remember quite exactly when I invented it. It must have been in the springtime. And the background to inventing this was that I was working with the original author of these ideas in the data model, and we were working inside an open plan office, and our general standard way of working was that we would paste pictures of data models all over the place, and that would be our way of remembering things. But because we were in an open plan office, we had nowhere we would actually, no physical wall space near us. I mean, there was walls, but not near where we were. And there were no physical wall space for us to look at these data models. And I went to dinner one night. Let's call him Fred, because I haven't got his permission to use his name in this video. So let's say Fred and I go to dinner, and we were like, damn, I can't remember all the things we're doing. Well, I can't remember the data models without pictures of data models. And we were talking over this during dinner. And Fred said to me, you know what us old guys need? And he was a fair bit older than me, but of course I was getting older, and that's good. He said, what we need, we don't have an expansion slot in our head, so what we need is some way of designing data models where we don't have to remember what they look like. We should just be able to build data models without remembering them. And that'd be really good for me getting older. And that's kind of how he put it. He put it as in, we need a way of building data models where we don't need to remember what the data model looks like. And of course, as a professional data modeler, one of the top data modelers around, that seemed like a pretty crazy idea, but a great idea nonetheless. If we could invent a way of designing data models where we didn't have to remember what the data model looks like, then we could develop more complex data models. And so I went to bed that night, and my brain worked on it. And in the middle of the night, I woke up with the idea and wrote it down. And next morning, I met Fred at the office, and we went for a cup of coffee. And I said, I've got an idea I want to run by you. Remember yesterday at dinner how you said we need a way of developing data models that means we don't have to remember what the data models look like. And he said, yeah, I remember saying that. And I said, I've solved that problem. And he looked at me and he went, you're kidding me. You think you've got an idea that solves that problem? And I pulled out a piece of paper and I said, what do you think about this? And I drew the answer to the problem for him. And he looked at me and just said, you are one of the most brilliant people I've ever met. He said, that is a brilliant idea. I love it. And this man, I swear to God, is the best data modeler on the planet. He is so far in front of me, it's not funny. I've never met anybody quite like him. Watching him work is like watching the mind of God work. And then we spent the next couple of weeks working on more models, And we developed these incredibly complex and sophisticated models using this idea. And it was great. And then in June or July, at the end of my stint over there in 2002, I was going on holiday, and I had a spare ticket back to Norway because I had a client in Norway, and they were my first implementation of these sorts of data models. So I was going to go from Norway over to Sweden for my summer holiday. So I flew into Norway, and I emailed my client and said, I've got an idea I want to show you. And so if you buy me lunch, I'll show you a really good idea. And buy me lunch was the work cafeteria. I met him at his office. Lunch was the €2 or €3 work cafeteria. So it wasn't exactly a big investment in lunch. So he said, yeah, I'll buy you lunch if you think you've got a good idea. And we did the idea before we did lunch. And so I went and said, okay, you understand how the models work that we implemented here. What if we add this idea? And I just drew the idea on the board and showed it to him. And he went, oh my God, that's brilliant. He said, that solves a lot of the things that we've been looking at. That's just, I can't believe I didn't see it myself. And what happens when people see this is they look at it and go, I can't believe I didn't think of that myself. It's like all good ideas. It's a brilliant idea. It's very elegant. It's very simple. It's very easy. But it's very hard to come up with it in the first place. And this is what I'm going to show you now. This was my contribution to the design techniques. But more importantly than that, what this means is you don't have to remember anything about your data models, really. If you want to draw pictures of them, then great, and a lot of people do. But this means you don't have to do that. It also means it archives the data perfectly in the data warehouse, right? That's the two aspects of it. Now, the archiving the data perfectly in the data warehouse was already there. The mesh, the joining of everything, was my idea. So let's talk about the Inman model for how to archive data. Okay, so if in the Inman idea you say, I want to archive customer data, address data, and financial score data. Okay, 3 things that you want to archive. If you apply time variance plus stability analysis, a la Inman from the early 90s, what you do is you break up the customer data into 3 levels, or any data into 3 levels: highly volatile, medium volatile, and low volatility. So what you do to archive data in the Inman model is you say, okay, we've got maybe 50 attributes of a customer that we want to archive, and we want to know the value of any field for the customer at any point in time for the entire life of the data warehouse. But of course, when one field changes, the other 49 don't. So storing 49 copies of fields is kind of wasteful, and disk was expensive then. So you break the data up into highly volatile, medium volatile, and low volatility data. You put the natural key at the front, and you put a date from, date to, and I added a current flag some years later. In his early work, Bill didn't have a current flag, but I happen to like current flags. He was talking about a high date for date 2, but I don't like to use high dates for date 2s. Just me, right? I don't like to have a field with any meaning in it. So if you use a high date in date 2 to represent a current date, a current field, then you're adding meaning to the default value. So I put in current flag. Yes, very minor thing. That's how I like to do it. But you split highly volatile, medium volatile, low volatility data. Okay. So some high volatility data might be customer accumulated balances or customer balance across all accounts. That would be very volatile. That would change every day. Medium volatility might be things like credit score or demographic or something like that. That only changes once a month, once every 2 months, that kind of thing. And low volatility data would be things like sex, domicile branch, opening branch for bank accounts and things like that. You don't change your domicile branch very often. You never change your opening branch. You never change your sex unless you live in Sydney or San Francisco, things like that. So there is some data about customers which is very low volatile data, doesn't change if ever. Some medium volatile data like credit ratings, credit scores, things like that, need to change them once every couple of months. And then some very high volatile data such as overall balances, number of transactions for the last week, those kinds of things. For addresses, similar kinds of information changes. The number of people who live at the address, for example, might change. The name of the name of the street can change. Things like that. Financial scores can also change, and also in account information, things can change. So this is how Bell did the archive model, and archive data is great. Great example of archive data in Australia was a major manufacturing company had used asbestos in the 60s and 70s, and people were coming forward in the 90s saying that they'd been poisoned by this asbestos. But the company didn't actually have an archive record of which builders worked on which sites. And the buildings that got asbestos in them, they couldn't tell if this builder worked on this building in either construction or demolishment or anything else like that. So they were faced with all these lawsuits without being able to disprove the claims of the people who were coming forward. Also in things like life insurance, which is a very long-term product, having archives of this information is just fantastic, very, very valuable. An archive answers this question, and this was the question that I started my very first project with. And what I was told by the director of marketing for the third largest life insurance company in Australia was exactly this. I want to be able to ask any question I can think of. I don't know what that question might be today, but I want the answer before I forget why I asked the question in the first place. That was the specification for a data warehouse. That was Easter 1991. And I'm like, what? You want to ask any question you care to ask, you don't know what the question is, and you want the answer fast? In business requirements, I was then used to designing business requirements of like, you have to know what it is that you want before we can build it, right? It's like somebody saying, I want a house, I want it to be a really cool, nice house. I don't know what I want it to look like, but I want it fast, and I want it cool, and I want it cheap. Can you build me a house like that, please? And the obvious answer is, no. You've got to give me more information, thank you very much. So we didn't really know, but an archive is exactly what you need to answer that kind of question. You just take all the data and archive it, then you can answer any question. And that's what Bill was talking about in the early 90s. Take all the data you can afford to archive and archive it, and then you can answer any question, which is obviously why Bill and Teradata at the time had such a great relationship, because in those days, the only machine you could put an archive on, the only machine you had a chance of answering those questions on was a Teradata machine. You couldn't put that thing on DB2. That wasn't going to work. So that was the Inman model of the world. Data is archived so any historical value could be found. Now an archive is hard to query, and I will recall the very first time I met Bill at a seminar that he gave. Well, I met him before on the weekend, but then we went to the seminar. But at the seminar I was sitting there and he's just talking about this method of archiving. And I put my hand up to ask a question and he said, yes, Peter. And I said, Bill, this data model is tremendously complicated. I mean, no query tools. You can't get a graphical query tool to ask a question of this data model, right? This is an archive and it's great and it's a great idea and I really understand what you're getting at, but you can't ask it a question with a standardized tool. What's your comment about that? And I'll never forget, there was over 100 people in the room, and he said the appropriate query tool for an archive like this is called a COBOL programmer. And it got a big laugh. Everybody laughed about it because they went, yeah, That's the only thing that's going to be able to question this kind of data model. There's no way any tools are going to question it. And it's going to run for a long time because there's so many joins with a between in it. You know, the date from date to had this between thing in it. One of the things I like about the current flag is when you joined across current flag equals, then you at least got the current image of the record came back fairly quickly. But for asking queries with betweens, it was, you know, on DB2, you know, this wasn't happening. Teradata, good machine to do this kind of question on. Now, Ralph came along and talked about type 2 dimensions, where, for example, customer data, all customer data is placed into one type 2 dimension. You can be selective about what changes to track, but you get 1 euro for every detected change, even if only one field changes. So the table grows to the rows equals the number of changes per year by number of years by number of customers. And it's linked, customer dimension, type 2, is linked to practically every fact table. But customer data is touched in so many places. Every query touching customer data is slowed down because number of changes per year by number of years, by number of customers. You got 5 million customers and they change 20 times a year, you're going to get 100 million rows in your customer table before too long. So people were very careful about which fields they detected changing around this. So a recommendation to get around this problem is in Managing Huge Dimensions in Ralph's book. Please go buy his book, it's a good book, which is in fact half a step towards associations if you actually stop and think about it. Now, even with bitmap indexes, the slowdown was very significant in doing customer dimensions like this. And this also applied to account data. So for customer and account data, you had the same problem. And so, you know, it was a real problem to have so many rows in the customer dimension and the account dimension instead of type 2 dimensions. But that was what was recommended, yeah? So what did we do about it? So all customer data is not tracked across time, is placed into the type 1 dimension. So customer party is a type 1 dimension. So 1 row for every party customer. The table grows to number of rows equals number of customers or parties if you've got prospects and things. It's linked to every fact table, but where is the history? Where are the other fields that we want to query on? Okay, because Ralph has got type 2. The fields are there you want to query on, but this is only the latest fields. So where are the fields? And here comes the genius. Okay, this is not my idea. This first piece is not my idea. All other data is broken out into separate small type 1 dimension tables. All distinct values which occur in the data set are stored. So distinct demographic, distinct psychographic, distinct product cross holdings, distinct memberships, distinct blacklist types. All the distinct values are put into small type 1 dimension tables. Then they are tied together through an association table. And that association table contains a set of keys plus date from, date to, and current flag. Because each distinct value is taken off the customer record and broken out and put into these other tables and then tied back together through this association tables, which links the keys, clearly from the association table you can rebuild the individual details of the customer. You can rebuild the customer image record at the time that association table was created. In fact, you can put a view over the top of it and expose it like that, right? And that means perfect archival of information from this association table. Now, these small dimension tables can be linked directly to fact tables, which gave us a big performance boost with bitmap indexes, particularly on Oracle. After all, when we analyze customer, we are usually analyzing the attributes of the customers, not the individual customers. So, as I said, psychographics, demographics, language, profession, memberships, cross-holdings, all these things are broken out, and those tables themselves are linked to the fact table as well as the customer table, right? So more keys, many more bitmap index keys, but bang, big bang for your buck on performance. Now the number of rows is the number of customers to access to individual customer, number of rows, because the number of rows to access to individual customers speeds up because the customer table is n times smaller. Okay, so whenever you're digging into the customer table, it's n times smaller than it might otherwise have been. So if you do actually go after actual customer data, which is not archived on the party record, it is much faster because that table is much smaller. Why are associations so important? In red. This is the only slide I do in red for this whole presentation. So here's the big red slide. It's important because an association flawlessly archives data inside a dimensional model without significant data redundancy. Almost no data redundancy, but some. So it archives data inside a dimensional model without significant data redundancy, thus removing the need for an archival layer of data without paying a performance penalty. Really important. Associations remove the need of an archival layer of data without paying any performance penalty, any archival penalty, anything else like that. Warehouses with associations run faster, cost less, easier to design, easier to update, and easier to write ETL for once you know how to write the ETL to support associations. And of course, CTL has inherent design support for associations. You just have to tell a mapping that it is an association mapping, and it generates the SQL for you. You can do one in 4 hours now. And I will give you an example. At a client that I did, I had a supposedly experienced Informatica programmer who took 180 hours to write the very first association mapping, and 120 hours to write the second association mapping. So 2 association mappings cost us 300 hours, for which we had to bill the client, and I was the project manager and I had to explain this. We can do those 2 mappings now in 8 hours. Okay, so what took a supposed Informatica expert 300 hours to do in 2002 can now be done in 8 hours. It's that much of an improvement. Okay, this is how important CTL is, and this is how important associations are. Now, let's just go over to an association table and see what. Here is the most important association table in BI4ALL, and it's the Party DIMS association table. That's what this one is, the Party DIMS association table. And what I came up with, the bit that I came up with was, let's put a primary key on every fact table, including the Party DIMS association table, and let's link this Party DIMS and account DIMS and any other associations we want. Let's link the associations everywhere. So you'll see what this means, okay? So here's the primary key, here's the string key that goes into it, and then here's all the association records, association keys, and there's 23 dimension tables linked, right? So what we do is we build up a record. The way that ETL works is we build up a record of the information necessary to build all these keys, to build the string keys for all this, and then we put it into a process where it performs all the lookups for all the parties every day and builds this set of keys. It then takes, let's say you've got 5 million customers. It builds a work table of 5 million rows saying this is the party key and this is what the party looks like now. And it takes that those 5 million rows of 23 keys and compares them to what the party looked like yesterday. And any party where it detects one of the keys has changed, it closes the prior record and inserts a new record. So it perfectly archives this information. Okay, so the party is tied to all the things I said it's tied to. It's tied for a date from, date to, with a current flag, and there is a process which says build this set of keys, look at the yesterday's version, see if any individual key has changed, and if it has, close the previous record, open the new one, and then if we join this record to all those dimension tables around it, we will get today's image of the customer. If we join yesterday's record with all the dimension tables around it, we will get yesterday's image of the customer. If we join the previous day's record with all the dimension tables around it, we'll get the previous day's image of the customer. If we have some date from, date to, and we say for date between, date from, date is greater than date from, less than date to, we can look at last year's January the 13th view of the customer. Okay, when we archive data like this, we can look at data at any point in the past as if it was a single joined together record with a date from, date to on it. No high, medium, low volatility, just different instances of the data that's associated with the row. And this becomes just a set of keys, just an index pointing to these dimension tables. Okay? So what you can reconstruct is the row image of what the customer looked like at the point in time for the date from, date to. Okay? That's what that does for you. Now this was my idea. I'm very proud of this idea. This gives you something really cool. If we go back to here, if we take the association table and we link that party association table to every fact table, okay? Now an association can be linked to a fact table, thereby linking all the tables linked to the association to the fact table. So for example, sales transactions. There were 23 keys on the party association table, right? We don't want to put all 23 keys on every table. We might want to put some of them. We might want to put psychographics. We might want to put address, right? But we certainly don't want to add 23 keys to every fact table where the vast majority of those keys, or a significant number of those keys, are going to be empty, right? What we can put on the fact table though is the primary key of the association record, the customer association ID or the party association ID. We can put that on the sales table, right? And that then links to the association and links to all the associated tables. And I'll just show you this. Here is our VF sales transaction, okay? Sales transaction. And here is DK VF customer DIMS ASOC, okay? That's the customer dimension association table laid right over the top of the party. So that is going to link to the primary key of that association record, and that is going to go to 23 dimension tables. So those 23 dimension tables are available to be set as constraints to come through the VF customer association table, DIMS association table, back to the sales transaction table. Okay? So that means no matter how many fields you want to add to the association, they can be linked through to this table. And what you will find in our data models is every table every detailed level table carries customer DIMS association and account DIMS association and campaign DIMS association. Remember earlier in the presentation I said, notice these three fields, I'll come back to them. These three keys, I'll come back to them. So here are the three keys: customer DIMS ASOC, account DIMS ASOC, and campaign DIMS ASOC. All fact tables, all three fact tables joined to every fact table, thereby creating what we call the mesh. The mesh means we can get from any fact table through customer, account, and campaign DIMS out to the dimension tables that they are linked on. Now, the other thing this provides a major advantage of is introducing new data. So let's say, for example, you go out and you get some survey results, or you get some census data, or even customers updating data about themselves, and that kind of thing happens. If you want that to be available against all your fact tables, you have to go and place it in a table which is linked to all your fact tables, which would usually be your customer data. But let's say you want this stuff over time, you've got some survey data over time and things like that. What you can do with this idea is you can create a new dimension table, put all the valid values for that new dimension table into it. You can link the customer association table to that new data, and even do that historically back through the archival records of the customer. If you can identify the value of that data and the change over time by customer, you can historically place that data on this one table. So you just update one table, add one key, link it for each row to the customer data. If you can link it historically, and suddenly this new data via this table is linked to all fact tables, and you didn't actually touch any fact table. Okay? No fact table was touched, and you might have 100 fact tables. No fact table was touched. Just this table was touched, and this link was added. And you can do this with almost any data associated with a customer. And you can archive any data you want this way, and you can take the association table and link it to any transaction table you want. Okay? This is a beautiful idea. Even today, I invented this 12 years ago, and even today when I talk about it, I actually go, yeah, this is a really good idea. So great ideas, and I like that. Now, keys can be placed on fact tables for performance. Okay, if you want to take this data and attach it to the fact tables, then that's okay. You can do that. That's not a problem. But you need to actually create the key on the fact table. Okay, if you're going to add, say, financial stores and they weren't already there, or some new piece of data you want to add which is not there before, you actually need to go change the fact table. Now, one of the things about this is if you add a key to a fact table, in general, you've got to change your ETL, right? And if you change your ETL, then you've got to test it, and all those things have to happen. So one of the things that you can do with CTL, with the C++ version if you use it, is if you want one of these fields, one of the association fields added to a table, you just change the table to add the field, and you don't change your ETL. It'll be automatically, that field will be automatically populated by CTL, no code changes. Okay? Because the C++ version of CTL has the facility in it to automatically detect if any of the association keys has been newly introduced to the fact table, and it will populate it without you telling it to do anything. So that was pretty cool. Now that doesn't work with the SQL version, of course, because with the SQL version the mapping is in SQL, so you actually have to change the SQL. In the C++ version, the maps were built at runtime in C++, so you didn't have to change the mappings. But this has been a really cool feature to be able to add keys to fact tables merely by adding the key to the fact table without having to change ETL, which means you didn't need any testing of ETL. You needed no move to production or anything else like that. You could just add keys to fact tables as much as you wanted with the C++ version of CTLs. So the other thing about that is, over the years, of course, what sent many of us data warehouse data modelers to premature grey hair was that you had this trade-off of the number of keys you wanted to put onto a fact table versus how much space they were going to take up and the performance impact of that. So you always had to decide what keys to put onto a fact table. Now if you put the thing into production and then you realized, oh, you know, I really do need this extra key in like these 20 tables, that's going to make a big difference to the query profile. You know, in years gone past, that was an expensive exercise to go change the mappings for 20 fact tables. Today, with CTL, C++ version, you just add the keys, they'll be automatically populated going forward. Historically, you have to populate the historic records. With the SQL generation version, you just go in, change each of the mappings, hit the rebuild button, and you can throw that back into production because you know that's going to work, because you know the SQL is going to be generated properly. Sure, you might want to go through a testing cycle, but very rarely will you find anything wrong in that sort of situation. So this removes one of the biggest modeling tasks, what keys to put on what fact tables. And this is a big problem without associations. If you don't know about associations, that's a big problem. So ETL is written so that putting a key onto a fact table in an association is trivial, and that used to be hard, and it can be automatic with CTL. So just again to take you back to the source code and demonstration about this. Here is a sales transaction. Here are all the keys. If you look on columns, here is customer DIMS association, account DIMS association, campaign DIMS association. So we will go through those. We'll go look at VF customer DIMS association. So here's customer DIMS association. Sorry, my bad memory. It's party DIMS association, and it's profiled for customers. Here are the keys. So from the sales transaction, we come to this record, this key, PKVF Party DIMS Association, which for a sales transaction must be a customer. We have then access to these 23 keys. Now party is, these 23 keys. Now of course party is also VN customer, but we have access to these extra 22 fields. Okay, so we can ask what did a party look like on a certain day and then go get the transactions back out. Okay, so that's party DIMS association. We'll just go to account DIMS association as well. And here is account DIMS association. Of course the account is there, but here are the other keys, and this is another 17 items. So that's 22 plus 17, and 39 dimension tables are linked through these two keys, one hop. Okay. Now of course anything else added to account, anything else added to party will be available one hop. So you know, pretty soon you can have 40 or 50 dimension tables linked to every table which is a detailed transaction for a customer against an account in two hops. Okay, one to the association table, one to the dimension table. This makes this extremely flexible. And in your data modeling, you can be pretty sure that if these two tables are meant to be linked together, they will be linked together, and if they're not linked together, you can link them very easily by attaching them to the association tables. That's how that is. So this day when I came in for breakfast with my colleague in 2002, the best data modeler on the planet, and I said, what do you think of this idea? Putting a primary key on what they were called profiles in those models, put a primary key on the profile for the party, the profile for the account. We didn't have profiles for campaigns back those days. And take the two profile keys and link them to every table, put an integer key on every fact table, and link, say, order lines to order headers, such that we link child fact tables to parent fact tables, and we link the association tables to every table, and we link all the dimensions for the association tables through the association back to the fact tables. What do you think of that idea? That's what he said. He goes, oh my God, that's a brilliant idea. And it is a brilliant idea. Even today, it's a brilliant idea. Okay? So it's kind of like that. And now you know, and this is why we do it under non-disclosure, because the idea itself is very simple. That's a fairly simple idea. If you don't use CTL, good luck coding that. If you use CTL, we've actually, of course, built CTL to be able to do that quite easily. Okay, so that's the end of the NDA confidential portion. If you signed an NDA about this, and you should have, please respect our confidentiality, please respect our ideas, and don't go handing this video out. Don't download it and hand it out. You may, if we can prosecute you, we will. So that was our great idea to share with you. Now, of course, this is the end of part 2 with an NDA. So this was actually, in fact, part 3 of part 2, because we split it out so that the video could be shared to people through the NDA, through an NDA, through a non-disclosure agreement, and everyone could be happy. Okay, so thank you very much for your time on listening to that. I hope you like that idea. I mean, that is, for me, that's the best idea I've ever come up with, and it's embedded in a lot of data warehouses I've built since 2002. Doing great work, that idea. So thank you very much for listening to part 3, the confidential under NDA disclosure part of part 2. Thank you very much for listening.